In this video, we're going to look at Section 3, Part 2. Last time, we were looking at the point of intersection of two linear graphs. We did this by plotting the graphs of both formulas in one coordinate system. First, we made the tables, then we plotted the coordinate system and both graphs. When we did this, you could see the graphs had a point of intersection, and we're looking for the coordinates of this point of intersection. So that's why we made the tables and we plotted the graphs. Then we could read off the coordinates of the point of intersection. But that really is a lot of work. In this part, I'm going to teach you how you can calculate the point of intersection without plotting the graphs. Well, last time I introduced this to you. We already know the coordinates of the point of intersection because we've plotted both graphs. And the point of intersection over here is 5, 3. The graphs are really different all over, except for this point, the point of intersection. At this point, they are equal. And that's something we can use to calculate the x value of the point of intersection. Last time I told you already, step 1, we're going to equalize. Both formulas are really different, both graphs are really different, except for the point of intersection. At this point, they are equal. So that's why we could write down 2x minus 7 must be equal to minus 3x plus 18. When we do this, we have an equation, and we can solve this equation. And when you solve it, you will find the x value of the point of intersection. Then you can use one of both formulas to calculate the value of the y-coordinate. So that is what we're going to do today. Well, first let us look at all the steps you need to do to calculate the coordinates of the point of intersection. Step 1, we already talked about this. Write down the corresponding equation. In other words, we have to equalize. Step 2, we solve the equation, and that's how you will find the x value. Step 3, we calculate the y value, and we do this by filling in the x value in one of the linear formulas. Step 4, check the point of intersection you found by filling in the x value in the other formula. So this last step is to make sure you did it right. Then, last step, and that's not really in the book, but when you are looking for the coordinates of the point of intersection, you're calculating those coordinates, please write them down at the end of an exercise. And we always write down coordinates between brackets. Always first x value, then y. So let us look at the formulas we used before. And then we're going to calculate the coordinates of the point of intersection. We will use the same 4 steps. So over here are the two linear formulas. And they are formulas because they have two different variables, y and x. We are looking for the point of intersection. So we're looking at the point when those two are equal. So step 1, we equalize. 2x minus 7 is equal to minus 3x plus 18. Now we have an equation, and we can solve this equation by using the balance method. First step, I want minus 3x to go away, so I do the opposite, and that's plus 3x. We do this on both sides, so 2x plus 3x will be 5x minus 7. On the right side, there's just only 18 left. So I did plus 3x on the right side and on the left side of the equal sign. Next step is this minus 7. I'm going to do the opposite. And when I do the opposite of minus 7, that's plus 7. So on the left side, we only have 5x. And on the right side, I get 18 plus 7 is 25. In the last step, I will calculate the x value. X is equal to 25 divided by 5. So this means my x coordinate is 5. In step 3, we are going to calculate the y value. And I can choose which formula I would like to use. It's either this one or that one. Just choose one. Because if everything went well, they will give me the same solution, because I'm looking for the only point they have in common. So I'm going to choose the first one. So I'm going to fill in my solution for x to calculate y value. Y is equal to, at the place of this x, I'm going to fill in 5. 2 times 5 minus 7. I'm just filling in the first formula. And then I'm calculating the y value. 2 times 5, that's 10, minus 7 is 3. So at this point, I really could write down the coordinates 5, 3. But to make sure I did it right, I'm going to check if the second formula is giving me the same solution for y. Then I'm really sure I did well. So I'm going to fill in x is 5, but now in the other formula. If everything went well, the solution will also be 3. So I'm going to fill in as solution x is 5 minus 3 times 5 plus 18. Minus 3 times 5 is minus 15 plus 18 is 3. So now I'm sure the coordinates of the point of intersection are 5, 3. 5 for the x, 3 for the y. So now you know how you can calculate the point of intersection of the graphs of two linear formulas.